Okay, so for this question we need to first of all plot the graph, and it's always worth having a quick read through over the other things just to work out if there's anything else we might need. Make sure your calculator's in degree mode here. If it's not, then if you click menu and settings, you can change it and make sure both of these say degree in them, and the float 3 can actually be changed to float 9 as well. So we're going to write down the equation, which is 2 tan of x, and it's x plus 30. And when we plot it, initially we just get a straight line, which we know that tan is not equal to. But if we look at the function here, it says that we should be plotting it from -90. So if you double click the end of the axis, that will change it, and through to 360. And then we should have from 20 to -20. On the y-axis. So now we have the actual function drawn, and the first question, part A, asks us to sketch the graph onto the axis. And I would always start with the asymptotes. So we're not sure on this question where to find the asymptotes because we don't have a denominator to make equal to 0. So if you're wanting to find them, we can do Control T, and we're looking for where x is undefined. So where x is undefined, and if we keep scrolling through this, eventually we should find some values where x is undefined. We just passed one there. So x is undefined at 60, and part C, asks us to find the two asymptotes of the graph. So we know that one of them is x is equal to 60, so we can already fill that one in. And the second one, now we know that tan graphs usually oscillate every 180 degrees. So the chances are it's going to be 180 plus 60, but we're checking through all of them just to be on the safe side. So if we keep going through, and we can see the other one's 240. So x is equal to 240 degrees is my second one. And you don't really need the degree symbol there. And then if we want to get rid of that, we can do Control T and the table will go. So we now need to copy this onto our axis that was given to us in the exam paper. So if this is 360, then we've got 180 roughly in the middle. And we've got 90 around there and 270 around there. So we also need to make sure that we know where the graph crosses the axis, so we're finding the zeros, because that's something else we need to label. So it crosses at -30, $150, and 330. So we've got 3 places that it crosses our axis: -30, 150, and 330. And we've got our asymptotes at 60 degrees. And at 240 degrees. Oops. Now we could actually erase these parts here. I was just using that to kind of find roughly where the values might be. And now I can just copy my graph onto the diagram. So it comes down here through 30, and then it sort of disappears, and I don't see how far that goes. The next one comes up, through, and then up. And my last one kind of disappears there. So I would now get all the marks, which are for showing where the asymptotes are, where the graph crosses the axis, and if I had any maximum and minimum points, so like the top of a hill and the bottom of a valley. Part B then asked me to find the solve the equation f of x equals 5. So what I need to do is draw the graph of y equals 5 onto my axis, and I can plot that onto my graph, which is roughly around there. It's not very straight. Yours will be better. And then we need to find where the intersections are. So the points of intersection, we have one there, and then we have a second one further down. So we have two solutions to the graph of f of x, which is the black graph there, is equal to 5, which is the pink graph on my GDC. Now notice the actual question, f of x equals 5, it doesn't actually have any y values written on it. So I'm not interested in the y value. We know that y is 5. So it's the x is equal to 38.2 and x is equal to 218. Okay, so for this question, the first thing again is to plot the graph onto my GDC, and it's a fraction with the equation x squared, or the expression x squared on the top, and then on the bottom we have x squared minus 2x minus 3. And then we need to check where the exam question has asked us to plot it, and it goes from -5 to 5 and from 4 to -4. So I need to set that up on my GDC, and I can also do it through window settings, and then change them on here. So the x goes from -5 to 5, and the y values go from 4 to -4. Okay. So it looks like we've got an asymptote on there, and if we look down at the questions, it does ask us in part 2 to find the solutions to the 3 asymptotes. So as normal, I would always draw the asymptotes on first. You are going to get marks for kind of the placement of those and the rest of the graph. So we know that we can find an asymptote using the GDC, using Control T, and we see one of them there straight away, which is x is equal to 3. And if we scroll up, we can see another one at x is equal to -1. And we also have one, we have a asymptote for y, and it's saying what happens to x as we continue getting larger and larger and larger. So if we look at the value here of the function, the one that's highlighted, then as x is getting bigger and bigger, it looks like it's getting closer and closer to 1. So the chances are we're going to have y equals to 1. And we can actually check those by hand. So we know that an asymptote happens when the denominator is equal to 0, because the function is not defined at that place. We cannot divide something by 0. So I'm just going to factorize my denominator here. We've got x squared still on the top, and then we know that we can change the denominator into x and something times by x and something. So we're finding two numbers that add to make -2 and times to make -3. And they're going to be 3 and 1. Now if we're adding to make -2, we want -3 add 1. That would make -2, and we can check -3 times 1 is equal to -3. So we have one asymptote when x minus 3 is equal to 0, which is where my x is equal to 3 comes from. We have a second asymptote when x plus 1 is equal to 0, so that's where my x is equal to -1 comes from. We also have a third one, which is the y-axis, and that's saying what happens to x, what happens to the function as x becomes very, very large or very, very small. And one way we can find that is by asking ourselves what the biggest value or the biggest power of x is in that whole function. So within my original function, the biggest power of x is x squared, and I have 1x squared over 1x squared. So that's where we get the y asymptote. 1 divided by 1 is equal to 1, so y is equal to 1. So now we can sketch those onto our graph. So the first one, that's not a very good placement. So the first one is 3, x is equal to 3, and the second one is x is equal to minus 1. And then we also have y is equal to 1, which we know that the graph can cross the horizontal one. The horizontal asymptote is not a hole in the domain, it's simply describing what happens to the graph as x becomes very small or very large. And from there we can start to plot on my function. So we have, it's very kind of 90-degree like. And then the second one kind of comes down here, and my guess is that further on it would actually do something like that. It's just that we can't see it because it's going to come down to that asymptote. And I think it goes through 0, 0, but we need to double check. Looks like it does something like that. So let's just check if it crosses the axis anywhere. Sorry, my GDC is not behaving itself. Okay, so yeah, it crosses through at 0, 0. Let's move that back. So we know that I can also label onto my function 0, 0, where it crosses through. So I need to write down the coordinates of the local maximum point of the graph. So the maximum point can be found by doing menu, analyze graph, and maximum point. My laptop is very slow. And it looks like it's going to be around that maximum point, the 0, 0. So we can just double check that, and it is. It's at the coordinate 0, 0. So the maximum point is the top of a hill. The only hill, so to speak, that we've got on this graph is the bottom one, and therefore we have the coordinate 0, 0. And then it asks us to find the coordinates of the local minimum point. Now, it's hard to see where the minimum point might be. And a minimum point is like the kind of the lower bit of a valley. If we click on to finding the minimum point, if you're not sure, you can kind of test different areas of the graph. So I'm going to start on the left-hand side. My laptop is very slow. And I'm just going to see if I can find a minimum point anywhere. Okay, so if it's kind of dragging with your kind of window, then that means it's not yet found it. But you can see there it's now stopped dragging it. So it has found a minimum point, which is at -3 and 0.75. So it looks like, although I've drawn it like that, maybe it actually kind of has more that kind of shape rather than being an exact 90 degrees. And then the last question says, solve the inequality when f of x is bigger than 3. So I now need to go onto my graph and plot the line 3. There we go. And we can find where the intersections are with my original curve. Sorry, my laptop's really slow. And it looks like the first one is at -1, 1, and 3. So -1.1. Just going to sketch it onto my curve. So it's something, it's a bit higher. Something like that, where this carries on. So the first one's at -1.1 and 3. And my second one is at 4.13. So 4.1 and 3. So you can see here what I've drawn on my graph clearly wasn't very good, because this is supposed to be 4.1 and yet this is 5. So something's not quite gone right with my graph. So you've got 4.1 and minus 1.1, and it's asking us to solve the inequality for when our graph is bigger than it. So where the graph is larger is this part here, less than the orange line. And therefore, I need to write some sort of inequality to show what values of x we have for all of those areas of the graph. So there's 2 different areas, which means that I need to write it as 2 different inequalities. The same as if I was doing less than. If I did less than, we would have 3 different areas. You'd have one here, a second one here, and if we had it, a third one there. But we're doing the ones above the graph, more than. So we've got the 2 sections. The first one goes from minus 1.1, which is where it starts at the intersection, and it keeps going until we get to the asymptote, which is at minus 1. And it's whether or not we have it equal to. It can't be equal to minus 1 because that's an asymptote and the graph can't be minus 1. And then on the other side, it can't equal minus 1.1 because at that point it's 3 and it's asked us for less than 3. So then my second region is where x is between the asymptote 3. So even though we can't see it within our range, in reality it does keep going up here until we get to 3. And then it stops at the point 4.1, and again it doesn't include either of them because that's an asymptote and it's at the value where it actually equals 3.